All right, this video is for the lesson 8.8 homework. Today we are doing horizontal and vertical shifts. So we're going to be moving the graphs of these quadratics left and right and up and down. So number one, what is the name of a change in size or position of an object? That is a transformation. And then number two, what is the name of a set of basic functions from which related functions are derived by transformations? These are parent functions. So we did this a little bit way back when we did linears. So parent function of a linear, the parent function is f of x equals x. It's just a straight line. Of a quadratic, though, the parent function is f of x equals x squared. Every quadratic that we have done anything to in the past 3 units has started out as x squared. That's the basic original quadratic function. Everything else that gets added onto it is us moving it or stretching it or reflecting it. That's what all those numbers mean. All those other numbers mean. Okay. I kind of got to get in the mindset to do this. All right, these first two, we're moving up or down. The page, I'll tell you that I still use when I do these, is the little half page from yesterday. This one, okay? So like here, we're going up or down. You can look at this and you can see what they're doing. They're adding something to the very, very end of this quadratic. Okay, so if I'm taking this quadratic, negative 13x squared plus 6x minus 5. If I'm going down 9 units, I'm going to subtract 9 from the end of this. And then all I do is I combine the like terms. I combine the negative 5 and the negative 9. So negative 5 minus 9 gives me negative 14. Okay, so if I'm moving it up or down, so if I'm going up, I'm going to add something to the end. If I'm going down, I'm going to subtract something just from the very end of the equation. So if my parent function was x squared and I wanted to move it up 5, I would do x squared plus 5. Just add the 5 to the end. Okay? So going up, we do the exact same thing. So what we've got to do, though, we don't like this form. Okay? I need to simplify this. So what I'm going to do first, so we got a little bit of everything today. I'm going to distribute this 3. That's the first thing I'm going to do. So 3 times 2x is 6x. 3 times 1 is 3. All right, so here's what I have now. And then I FOIL it. So it needs to be in standard form. Before I do anything to a function, shifting it mathematically, it needs to be in standard form. All right, so first, 6x times x is 6x squared. Outside, 6x times 5 is 30x. Inside, 3 times x is 3x. And then L for last, 3 times 5, is 15. Combine like terms. 30 plus 3 is 33x plus 15. All right, now I can do this. Shift 11 units up. All I'm going to do is add 11 to the end. And then combine those two last numbers. So I would have 6x squared plus 33x, 15 plus 11 is a 26. So if everything else stays the same, all that's changing is the very end. It's moving it up and down. Okay? Left and right is where things start getting wonky. Okay? If I'm going to move something to the right, I'm going to subtract a number from x. If I move it to the left, I'm going to add a number to x. So it's like backwards, because normally if we move right, we're adding, and we move this way, we're subtracting. So it's just opposite with the left and right move. Okay, so when I do this, now I've got to remember how to do it. Ooh, these are the ones that I hate. I hate these. Let me pull this. Okay, let's do this. So here's from our notes last night. All right. So what they've done is they've got their functions written in vertex form. So I need to write this in vertex form is what it looks like to be able to do this. Okay? So let's write this function in vertex form. It's not hard to do. I can take this function and I can put it in my graph. All right, 4x squared plus 15x plus 18. And then I can find the vertex. It's a minimum, so menu 6, 2. Ooh, that doesn't look right either, though. All right, let's look at number 6 really quick. So this one's already in vertex form. All right, when I'm shifting left and right, I do it just to the x, okay? So if we're going right, we're going to subtract 6. So just to the x, there's already being a 1 added, but I'm going to subtract a 6 as well, okay? And then I'm going to simplify this down. So 1 minus 6 is a negative 5, so I've got x minus 5. And then I've got to break these pieces down. So I'm going to do x minus 5 squared first. And I'm going to FOIL it. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. Combine like terms. Okay. Now, I still have, though, this 2 out here and this plus 7. So I'm going to distribute this 2. So 2 times x squared is 2x squared. 2 times negative 10 is negative 20. 2 times 25 is a positive 50. And then I've got that plus 7 on the end. Combine like terms. 2x squared minus 20x plus 57. And I'm done. Now you can see why I hate these. Here's the bad thing about these. There's typically at least 2 of these questions on the EOC. Okay? So the ones that I put on the unit test are, I'm actually going to show them to you ahead of time to show you what they look like. Okay? They're not as complex as this. Okay? What you're going to do at the bottom, all you're doing is moving here. No math. You're moving shapes. Okay? So we're going to do this one together, 3 units up. You need to pick you at least 3 nice, pretty points. Okay? So the vertex is usually a good point. And like this one's got x-intercepts. All you're going to do is move each of those points up 3. 1, 2, 3. There's that one. 1, 2, 3. And then this one, 1, 2, 3. And then connect the dots. Hey, Destin. So I'm going to mark the nice pretty points on the other ones for you. And then I'd use these 2 points. So this one you're going down. You're just going to move the points 2 down. connect the dots. Here you're going left. These are kind of gross. Let's say these two. And then this one. This one and this one. Okay, so just all you've got to do on your own today is make the movements. Okay?